So as you recall, last segment we discussed supernovas and how gold was forged. This, in Geology and Gold Part 2, we're going to discuss the remainder of how geology affects gold and what you need to know about it. In particular, gravity. Over and over again, we keep seeing gravity playing a role in gold mining and gold prospecting. Understand that's the one single physical phenomena that you really need to understand well to do well when you prospect for gold. And so I'll just keep bringing it up. But that's why it's here so often. That's also why it comes in when we talk about weather, because it affects rivers, glaciers, and their valleys. All this plays a role in knowing where gold is going to go, knowing what it drives it there, and how to hunt it down, because you know the clues of where gold goes when a storm hits. But you also know the clues of where gold came from. And we'll get into that later, but that gets into what lode gold is and how we can find it by hunting down the clues hidden in placer gold findings. You see, the big ticket item is to find a gold lead. These are fissures or cracks with a stringer of gold and quartz that could make you rich beyond your wildest dreams. But you have to factor in an understanding of how water works and how the flow drives gold. I'm going to keep emphasizing that water because it plays the biggest role in what you see beyond that supernova, which you're fortunate not to have seen. Gravity, number one. It pulls the planets together from the dust and accretions. We'll call it interplanetary junk, but these objects smack into each other and generate heat from friction. They also generate heat from all that radioactive decay from the supernova. The end result is that the outside insulates them and starts to melt the inside. And from the inside out, this forms a molten core of iron and nickel that collapses inward again by gravity, releasing even more energy. And that heat buildup causes the whole interior of the Earth to melt. And to this day, it is still molten. Down below the crust, the area is called the mantle, and this is where volcanoes come from. It is also where gold is sitting saturated in rock and high-pressure liquids that are silicon and water together. These things drive up and form the cracks. Fast forward to almost today. The Earth with its oceans and its major continents. The continents are lighter rock materials floating on top of that heavy and dense magma, which is loaded with iron, nickel, and heavier elements. Because some elements can actually go into solution with the silica, they get driven up through the crust in areas where there's a subduction zone, which creates an opportunity for remelting of crustal material as well as for magma to make its way to the surface in extrusive volcanoes and intrusive dikes and batholiths like the Sierra Nevada. These rocks are loaded with metals such as gold and silver in water-based rocks as well as quartz and sulfides. One of the big hints is that those sulfides and those metals will have dark colors, rust colors. Redder the better is what we say. So you're looking for these clues when you look in the rocks themselves to see if they might have gold in them. Now, in this image, we're going to be looking at how mountains are built. And you take those mountains and add in a little bit of water in the form of rain, heavy rains, storms beyond belief, floods. Gravity drives that water down again, releasing energy again that came from the sun. And that acts on those mountains either by ice And frost in the form of glaciers or in the form of melting glacier snow and water from rainstorms. That releases energy. The energy goes downslope, tearing off the top of the mountains, cutting valleys, and giving rise to mountain plains. And these alluvial plains, where all the sand and gravel and boulders deposit gold with them because it came out of those intruded areas that had gold in them. These are quartz veins that are forced into the rock. They call them quartz stringers, with gold or silver or other precious metals in solution. We'll get into that in minerals in the next video.